Okay, we had some good discussions and the breakout rooms. I think the team one, if you could share your screen and kind of walk through your pseudocode, that would be great. Could you have somebody that could do that?
Who's team one?
Manish, are you going to do that for us? Thank you, man.
Oh, sure. All right. Sorry, I'm on a tablet. So would someone else on my team be able to share a screen? Great. So the beginning part is getting the binary image and with the isolated one image. So that's where combining what we did in the past 3 activities, where convert the color image to a grayscale and then using the 0.5 threshold to get a binary image. And then we want
Manish,
to
let me stop you there.
Let
me stop you real quick. So you guys asked the question, should we read all the images in or just one image? And I suggested using one image at a time. So you might have an array or a list of all of the names. So you make it real easy for the reviewer to, select an image, okay?
Okay. Right, they just change the index.
Okay. Yeah, change the index or have them all listed so it's easy to select, and so that the reviewer doesn't have to do all that.
Okay, we can do that for reading in the images from the file. Okay. So once you have that list, then you can read in the appropriate index based on the one that's being tested and get the binary image using the 0.5 threshold from the grayscale. And then we want to get rid of the small folders and small objects and leave only one object. So how you can do that is once you have your images that have been, your objects that have been created, you get the area of each of those objects using the region props, and then using that, you can do the remove small objects function with the size parameter set to 1 minus the area of the largest object. So that way it removes everything except for the largest object. And then to rotate that one remaining object to get it vertical, you do the rotate function with 360 degrees minus the degrees unit conversion of the orientation that has been outputted. So for symmetry, and we can get a chance to write it down, but how we were planning on doing this is getting the coordinates of the border for all of the for the object and comparing that with the distance between the centroid point and each of the borders of the object. Once you have that, you can compare the lengths of each of them to figure out, okay, how related are they? And by doing that, you can compare that with the, because ideally the radius should be the same for all of it. And you can determine if, okay, it's not symmetric if you have significant differences in certain parts of the object in the radius between the centroid and the distance. And that's where you would have a threshold that says, okay, if you have this much difference between the centroid and the border, it becomes a yellow versus a red. And a similar,
I think that's a really good technique. A couple of comments, right? So what you just described is get the points on the perimeter, the XY coordinate, and then compare that distance to the centroid of the object. And you might think about, well, okay, what's the mean value? And then what's the standard deviation of all of the centroid to perimeter values? And if you have a wide standard deviation, that means you have a large variance in the jaggedness of the border. Now, I do not know if you can get all of the XY coordinates of the perimeter, but that's a really good technique.
Okay, yeah. Yeah, so we can use that variance and the standard deviation to figure out how consistent it is, and based on that, the threshold can be set.
Now, the other thing is you may not need every
And so
point. You may not need every point on the perimeter. Maybe you use, you know, the top 10, 100, 50, whatever, right?
right, because every point would be a little inefficient and make it run.
Yeah, and it maybe you can get the perimeter points by some other method, not returning every perimeter point. So that's maybe a hint.
Okay. Okay. Yeah. That seems good. So then for determining the jaggedness characteristic, we want to compare the ratio of the perimeter of the object with the circumference of the ideal circle, perfect circle. And how you could do that is by getting the average of the major axis and the minor axis length of the object. And that average would be the radius of your perfect circle. So using that radius, you can use the circumference formula to get the circumference and then calculate the ratio between the perimeter of the actual object with that ideal circumference. And that ratio would be your quantitative measure of the jaggedness. And using that, you can compare that with your thresholds, the yellow and red risks, to determine the jaggedness characteristic of that particular image.
Awesome. Good description.
Yeah, and then combining both of those, you can see like if either one of them are red, that makes it an automatic red. If you have both yellow, then that makes it a red as well. Versus if you had one yellow and one green, or both greens, then that would be a low risk.
Perfect. All right, cool. Did anybody do color?
We didn't get to that for us.
Okay, so for color, you might think about how you can plot out the histogram. And then if you have a lot of peaks in the histogram within a certain range, that means you have a lot of colors. Okay. Or
so that histogram would be of the color
of the grayscale. That's the grayscale. Or you could look at you could look at the red plane and see where the peak is and come up with a mechanism to say, here, the red peaks are here, the green peaks are here, and the blue peaks are here. That means we have a lot of colors. It's maybe simpler to use just the histogram of the grayscale and to look for peaks within a certain range of the Y values on the histogram.
If you use the grayscale, could that be confused by different colors that could maybe be represented by the same shade of gray?
Yeah, it could be, but I mean, the whole point is, right, if you have, you're probably going to have more than, if you have that happening, you're probably going to have more than a couple of shades, right? So you ultimately have a threshold on the number of peaks that you have. And we're not, here's the way to think about it. It's like you're not looking at the noise around the baseline of the histogram. You're looking at a region above a threshold that says, oh, we have N number of peaks across, across the whole histogram, and they're above this threshold. So that probably means it's got grayscale, a lot of grayscale values, which means that it is a color, it's got a lot of color. Now, you don't want to look at the background, right? You only want to look at the part of the grayscale image where the mole is, or the melanoma is. So that's another hint, I guess. All right, we're getting near the end of the hour here. Hey, a really good session. Thank you, Anish, for leading us through your discussion. Are there any questions? I believe you guys have either 3 or 4 days to work on this. It's a pretty cool little application. If you have any questions, you can send me an email. I practically, answer email all hours of the day. So I'll try to get back to you as soon as I can, okay? Victoria, you good?
Yes.
David, you good? Everything good?
Yes.
All right, you guys have a great weekend.
Oh, Professor Hanks, I did have a question about my code.
Okay.
Could I do it?
All right, let's sling some code. Show me your code.
Okay, so I know in office hours you had shown us like this, but I keep getting a value for the, let's see, for the y, I keep getting nan values. And I was thinking it might have something to do with like the way I try to get the biggest blob. But I'm not too sure. And then I tried to like take away by using like shortcuts to get rid of the nan values, like numpy.
So where are the nans occurring? What array are the nans occurring in?
They're occurring in the y for the coefficient.
Okay, so is that after you do the correlation? Or
Yes.
okay, yeah, just plot out your X projection correlation there, or your Y projection. I mean, just in the console, just put the variable name in and then hit return. So we can see what's in it. Because I think it just
Because I think the X, oh wait.
so yeah, you're gonna have to read up on this coefficient. Is you really there's only one of those values from the array that you really need. Okay, so you don't even
Right.
look at the nans. So figure out which one that you want to use. Is it 0, 0 or 0, 1, for example?
Okay. Okay.
So you don't have to use all, so you don't even have to look at the nans. So just look at the one value in the array that gives you the correlation that you need, okay?
Okay. Got it. Thank you.
Okay, take care.
Professor Hanks, one quick question. So, are we only allowed to use the import statements that we were provided, or can we import additional modules as well?
You can import different modules. The risk there is a peer won't have that module on their computer.
Oh, okay.
Yeah, so I would probably say, yeah, I think that's cool. And I would, there's OpenCV and some other things you could use, but I think the risk is the peer won't have it. So I would suggest you stick to what we gave you. Okay.
Okay. All right. That sounds good.
All right.
All right. Thank you, Professor. Have a
Take
great
care.
day.
Take care, man.